Everyone, my name is Neira and I am a member of TUM.ai Makeathon department. I've been hiding in the background for the past few days, but tonight I have the pleasure of welcoming the experts coming from two very different industries, namely semiconductor, Infineon, and Roche coming from pharma and diagnostics industry. Before we start, so this is already our second deep dive day in the Deep Dive Day series. We've started yesterday with NetApp and Siemens Healthineers experts, and we've heard some very, very exciting talks. And then tonight we will hear the experts from Infinion and Roche. The Deep Dive Day series continues for a couple of more days, and that means that there's only a little more time left for preparation. And then on Friday, we really kickstart the Makeathon and we start working on the challenges. So the first one to speak will be Infinion. On Infinion's side, we have a full team coming to tell us more about the AI environmental sensing and also more about the Center of Excellence of Artificial Intelligence in Infinion. So we'll hear Nico Kelling, Cecilia Carbonelli, and Lorenzo Cervelay speaking. Nico, are you already there? How are you?
Oh, good evening. I'm here. Thank you very much. I'm very happy to be here today with my co-speakers today. We are very happy to be part of this Makeathon here. Maybe let's get started also with our slides in parallel. So I hope you already had a good time to start this Makeathon, good group forming already and some good inspiration through the deep dive days. I hope we will give you some additional inspiration and some idea what can be done and what we are doing around AI, and that it's actually doing good for the society and addressing some of the problems of our time. And also we will try to give you some idea what specifically the semiconductor industry, what our role is in this activity as well. So today we have brought a team from various parts of our organization dealing with AI around there. Before we introduce our speakers a little bit more, maybe just a brief comment about the setup here, because I think it's important to notice AI is a cross-functional endeavor. It requires really different skills and expertise and different parts of the organization to work together to make it happen. And that's why I'm extremely happy really to have two of our really experts together with me today to speak about this important topic and to give you some insight of what we are dealing with. So maybe I hand over to Cecilia first to introduce you to start with.
Okay, thank you, Nico. So good evening from my side as well. My name is Cecilia. I'm a system and algorithm architect at Infinion in the Power and Sensor System division. In these years, I've been dealing a lot with the topic of environmental sensing, how to develop AI solutions for these specific products and sensors. I have a background, I'm coming actually from the telecommunication engineering and information engineering, so I have a background also in wireless communication networks and signal processing. I have been quite a lot with Infinion, 12 years with a short break at Intel. Free time, I wanted to pass on this question, but then I answered. So I have three kids, 3 daughters, and in the little free time I have left after work, I do go jogging, and of course I have to cook for family and friends, and I do like reading fictions in the evening when I'm done with work.
And thank you very much. I'm really honored to have you here with me today. And maybe Lorenzo, I ask you.
Thank you, Nico. Yes, my name is Lorenz Cervelay, and I'm a machine learning senior staff engineer at the group of Advanced AI, which is a small corporate research group at Infinion inside the radio frequency group. Actually, my work at Infinion is at the moment is a small prosecution of what I did in my PhD. I did I started at Infinion as an industrial PhD student, and I carried out my my PhD thesis and research within an industrial construct, which is actually also what Infinion offer, which is a very exciting possibility because you can unify like industrial and scientific experience. And then afterwards, I've been continuing in a kind of research setting within Infinion. So what we do in our group is like try to keep on innovation with machine learning, also applied to signal processing, and also in particular radar frequencies. And I am working mostly with like state-of-the-art machine learning methods in reinforcement learning, metric learning, geometric deep learning. So like most of the hot topic of machine learning, and apply that to real industrial problems. I have a PhD in computer science, as mentioned, that has been done within the setting of Infinion. And in my free time, I really like science, like the broad spectrum of science, so not only computer science, but everything. And I do like very much boxing. Thank you so much.
Excellent, thank you so much. So my name is Nico Kelling. I'm also a long time with the company, more than 20 years in many different functions. I studied computer science originally, have worked a long time in microcontroller business, in automotive business, and many topics related to software, and now heading the Center of Excellence of AI at Infineon. And maybe to elaborate very briefly what this means is, this is the first part of the presentation today. The role of our Center of Excellence is to coordinate this and to enable the various business functions to take advantage of AI and use it to create additional benefits, to make life easier, to make it safer and to greener. And I want to motivate this a little bit by starting with the global megatrends, which actually drive our entire industry, the microelectronics. So as you see, the common challenges of our time, the demographic change, the social changes, the urbanization, climate change, and especially the topic of resource scarcity are really driving and challenging for new solutions. All this goes along with digital transformation, things becoming digital, becoming connected, becoming electrified. And that's what really is driving our business as a semiconductor maker. The semiconductors are essentially the link between the digital and the real world. And based on that, AI then is one means that provides a contribution to solve some and to address some of these challenges outlined here. So this is really the heart of the semiconductor business. And if we move on to the next page here, we can see a little bit what this means specifically in terms of applications and how this is being used. You see the two mega drivers here, the electrification on the one hand side. You see quite a number of different applications shown in here, starting from originally possibly mechanical or hydraulic solutions, and step by step they get electrified, they get digitally controlled, and more higher loads are being driven. Think about this XEV, electric mobility. This is one big topic in our time, asking for new ways of energy transformation, regenerative energies, things like this. On the other axis, we have the digitalization trends, starting from simple to smart devices, smart systems, up to eventually even autonomous control systems. So what you see in these systems becoming more and more complex, they're becoming more and more smart. And this is where also AI comes into play. And especially when it's AI in the device, which is not hosted anymore on a central server only, but also this AI intelligence gets integrated into the devices, local to the sensors, local to the actuation, to the interaction with the machines, to the robotics itself. So this is when new applications become possible and really new solutions that enable energy efficiency, enable new ways of interaction with machines, enable new types of detection systems smart sensing of various things that have not been possible before. And you will see some of examples of these through the presentation today. Let's move on to the next chart. So as a semiconductor maker here, we say we are the enabler of AI and we are also a user of AI. Why is that? As a microcontroller provider, as a sensor provider and smart power and provider, this is of course the basis for executing AI models, the inference in the end. In this sense, we are the enabler of AI, providing solutions that are the basis to take advantage of these new technologies. On the other side, we are also using AI in-house in our processes and everything that we do in-house, from the innovation to the design and manufacturing of our components, also to all the way to selling those devices, bringing them to market and supporting our customers. So, and then accordingly, there's a range of these 4 different categories that we show on this chart here, using AI in our processes and providing solutions to our customers that really enable new ways of interaction with robotics, enabling collaborative robotics, enabling smart city systems or smart power conversion, a smart consumption of the electricity for energy efficiency and ease of use of these things. So as you see, there's quite a range of applications behind this. Let's move to the next chart, please. So you see, I touched on this, what we do in-house. By using AI, we make life easier, safer, and greener. And that's by providing solutions to the market, new enabling functionality for the market that provides benefits to the society, addressing societal problems, but also, of course, for our customers, helping them to create better products faster as well, but also for inside Infinion, for our employees, for our people, make the work more attractive, find better solutions to given problem. And this is going through all the different ranges from what we do inside, from the manufacturing, the supply chain, the development of products, but also within the products and services, and also in how we interact with customers, the customer interfaces, new types of services that we develop based on this functionality. So, and last but not least, on the next slide, I will show you one of the key results, how we use this. Energy efficiency and sustainability, of course, is one of the paradigms behind, one of the big targets that we are aiming for. We are committed to CO2 neutrality by 2030. And you can see some of this balance that we achieve today in this chart. On the one hand side, of course, we consume also CO2 by what we are doing. But on the other side, with the solutions that we provide to the market, with the improvements that we can generate here, we also enable a lot of CO2 savings in other applications, as I have briefly touched upon. And you see that already today there's a ratio of about 1 to 35 from the CO2 burden versus the CO2 savings that is being achieved. And of course, this is expected to further improve over the coming years. And I think with the coming examples from my colleagues here, you will get some very nice examples what this means, what solutions are behind, and what are some of the challenges related to AI when it comes to that. Because of course, we are certainly aware AI provides a lot of potential, a lot of opportunities, but also it requires responsible use of these technologies and to design these technologies in a way that it can that it provides these benefits, but at the same time also protects our values and the robustness and the explainability of these systems. All these aspects are also very important for us as a responsible organization here, inventing new applications, how to make use of AI for these social goods. So with that, I would like to hand over to Cecilia Carbonelli, and please, the stage is yours.
Great, thank you, Nico. This was the perfect introduction, so I don't need to say much more at this point. So for the next 20-30 minutes, I'd like to tell you something about AI and environmental sensing, specifically air quality monitoring. And before I do that, however, I'd like to introduce also the team that helped me to help put together these slides and some of the results I'll share with you. So Simon Mittermeier, Janyu Zhao, Sebastian Schopp, and Jos Rabari. And it makes sense actually to mention them because they're also all former TUM master students, which we were lucky enough to be able to hire after their master thesis. Well, Sebastian is still our PhD student, but is almost at the end of his PhD program. So I have structured now this presentation in 4 chapters. The last one is very short. The first one is about introducing this air quality monitoring topic and the low-cost environmental sensor. Then we will talk about algorithms for this low-cost environmental sensor, and we'll talk about challenges, the challenges of calibrating sensor and algorithms when we deploy then this sensor in the world, so to say, as products. Yeah? So first of all, what is an environmental sensor? So environmental sensor is basically a sensor that is measuring gases. Yeah. So and dependent, well, it could also measure liquids. So in this case, the focus is about gases, and depending on the gases or the mixture of gases that are being detected and identified by the sensor, we can basically come up with 3 categories. There is indoor air quality monitoring. If we are, for example, monitoring CO2 and CO in our office buildings, in our houses, yeah, in conference room, meeting rooms, we might be monitoring instead ozone or NO2 and CO. So in this case, is outdoor air quality monitoring. Or also in a very important category that is gaining a lot of attention in these days is the topic is the category of breath analysis. So we are monitoring actually our breath, and this is already going a little bit in the direction of tracking health and fitness conditions, so to say, yeah, of a human being. So today we picked the outdoor air quality monitoring, but you can see that many of the techniques, of the methods, and of the challenges that I will mention then in the upcoming slides actually are also typical of the other 2 categories. Yeah, so they share similar problems and similar solutions in many cases. So why is important to this outdoor air quality monitoring? Why is it so important? Well, if you, in principle, if you check the weather forecast on your cell phone, you also have, depending on cell phone you have on the app you use, you can also see what the quality of the air is in your town, in your city. Yeah, you can also monitor this on a website. Yeah, but this information is coming from few monitoring stations or few weather stations, rather expensive ones that are located at some specific places, for example, in Munich. So this information is not very granular. It's not granular in time, for example, also because it's being averaged over 1 hour or even over 4 or 8 hours, and it's not so granular also geographically, right? So having the possibility to develop local sensor that everybody can buy and use and have as a wearable, for example, or as a portable device, then really democratize kind of the access to this air quality information. Yeah? So for example, I could be monitoring ozone and O2 and CO and have an impression what is now the air quality around my house and decide to take, for example, another route when going jogging. But also cities and institutions could generate this heat, pollution heat maps are called, and then organize, for example, traffic and city management around it. Yeah, so it is a very important application. Yeah, so A little bit about the technologies. There are actually various technologies for environmental sensing, for gas sensing. So there is, however, one technology that is very promising, that is being used especially for outdoor air quality monitoring and also for the breath analysis use case, and also for the food industry application. These are chemical sensors. They can be very small, and still they're capable of detecting really gases in parts per billion, but even in parts per million, yeah, in terms of concentration. Now, this sensor, they have a rather simple working principle, so that the material reacts, basically reacts with the analytes, with the gas, and then changes its resistivity over time in a way that is specific of the gas and also the concentration of the gases. So you can already hear, okay, here there are patterns that I can try then to classify, identify, and assign to a specific gas and to a certain concentration. Yeah, these sensors are also being heated, yeah, between a low and a high temperature, so as to increase sensitivity and also dissolve the molecules after a gas absorption or after an absorption event. So this is all good and fine. So, but what are then the challenges for us as algorithm experts, as machine learning experts, and data scientists? There are a few challenges related really to the specific hardware and technology. So these are chemical sensors, and as such, it can be that there is one dominant gas, for example, that is masking the other analytes that we might also want to detect, or preventing other gases from attaching to the material. Also, this sensor can be a bit slow, so they have a certain inertia, and they can drift over time. And although the sensor-to-sensor variation is quite good, yeah, for this material, still the behavior over time needs to be characterized. And also another thing that we need to characterize is also the cross-sensitivity to, for example, to other quantities in the environment, like temperature, pressure, humidity, or even other gases. Yeah, so these are all the challenges we have to keep in mind when we design our algorithm for this low-cost environmental sensor. So far, I haven't mentioned the word AI. So, but don't be too disappointed. Here it comes. So, while developing algorithm for environmental sensor, actually we had the opportunity to touch on so many different AI topics, yeah, starting from the very basic concept of feature engineering, designing the architecture of your neural network, tiny ML design. This has been also a big topic for us. We will briefly also mention this again later on in this presentation, but we also looked into explainable AI. We looked at network decision, feature importance, feature ranking, Bayesian neural network. Yeah, I'll cover that too later as well. And in these days, as we kind of increase our measurement capabilities, we are measuring our sensor in the lab, but being this outdoor sensor, we need to measure them also outdoor. We're of course collecting a lot of data, and it's clear that we are also dealing then with big data analytics. We are dealing with the challenge of deploying an AI model in a product, but also topics like transfer learning, or as this sensor multiplies, we also need to look at, of course, defect detection and predictive maintenance. These are rather recent topic now, these orange ones, yeah. So let's continue and let's look at these algorithms for low-cost environmental sensor. So first of all, a very basic question we asked ourselves, and I'm sure if you have done the same with other sensors, other applications, you have probably also asked, this is the very first question we have to ask ourselves, is AI actually making sense? Yeah, is it just over-engineered or too complex, yeah, for this specific application? So in the case of environmental sensor, especially of the technology we are targeting, we soon realized that traditional algorithms were not competitive enough. Yeah. However, we also identify a couple of nice features within this application. First of all, we are in a very advantageous position at Infinion because we can measure these are our own sensors that we develop, and we have our lab facilities where these sensors are being measured. So we are the master of the data. We decide how to train the sensor, we decide what measurement profile we select, what the combination of gas concentration we want to basically consider, and we want to expose our sensor to. So the other interesting feature is that inference, for the case of environmental sensor, you'll see, is not too complex. That means that the algorithm and the model, the trained model, can be easily deployed also on small microcontroller units, so to make a smart sensor. So it's really an edge AI application. Nico has mentioned this earlier, right? And the other nice feature, and that's really also the fun part sometimes of what we do, is that AI algorithms also helped us characterize our sensor and in return improve the technology, also internally for our internal stakeholders. Now, going back to the traditional approach, just a very simple slide. This, as I said, we soon realized that it was not possible for the specific application and for the specific technology to find an analytical or simple linear solution that would map the change in the resistance to the concentration of 1 or 2 or 3 gases. Yeah, linear. It's not a linear relationship, and even trying to find a table or a lookup table, this would need to account for time, for temperature, for humidity, for a lot of other quantities. So it would be a huge lookup table. And in contrast, the neural network we're actually dealing with are not so big. Yeah. So we, at the beginning really of our activity, we did our own work and we tried to place our application in the AI landscape. And we, of course, went through a lot of algorithms, like a linear regressor algorithm, like a linear solution, but also other machine learning techniques like random forest. And we realized that simple neural networks were actually competitive in performance, and we had a very, very small memory footprint that made them really competitive for the edge AI use case. So also something I wanted to share with you is now what is our AI workflow. So if you are a machine learning engineer or a data science scientist at Infinion, what are your interfaces? With whom do you interact as you go through the AI cycle, so to say? So in the beginning, you have to surely define the problem, and this you do interacting with the marketing and application engineering team. So they know the customers, they have competitor analysis, they start defining requirements. So together with them, for example, in the early days, we ask ourselves: so shall this be, first of all, which gases we want to identify? Is it indoor, outdoor? Is breath analysis? Is this going to be a gas classification or like a traffic light classification, like the air is green, is orange, or is red? Or do we want really to quantify the gases? So it's a classifier, it's a regressor at the end of the day. So after this was more or less decided, so requirements are often being then refined later on, but then we moved towards the task of creating a database. So we created really labs where the sensor can be measured, where we have analyzers that are giving us the ground truth, and once so we have a lab team behind us. We are not the ones taking the measurement, right? So and we interact, and we go through a lot of iteration also to improve also our profiles, our measurement technique, yeah, and our measurement protocols, we call them, and procedures. So once this is done, then we are confident about our database, about our ground truth. Yeah, we start then thinking about the concept. So what neural network do we need? What features do we want to extract? Of course, sometimes we come back to this and we do add some new features, or we improve something in the parameters of our on our network architecture. But at the same time, we also start looking at the size of these models, the number of operations. And as I mentioned earlier, for our very first implementation of our recurrent network, we ended up being able of embedding the model and the libraries in a very, very small, on the smallest PSOC of the PSOC family. And this was presented also last year by a colleague of mine at the Tiny ML EMEA forum, if you are curious to see that publication. So once we have the algorithm, we have the sensor, the technology, we have the electronics around it. Of course, we also have, normally we also have a customer demo that we can show to the customer, and we can then convince him to look at least at our solution and at our technologies. So another important topic and area of research for us is the area of trustworthy AI. So it is clear that a neural network is not a completely transparent system, yeah, but it doesn't have to be a black box system. So nowadays there are lots of techniques and methods from the area of interpretable and explainable AI. These are actually two different things. We don't have much time today to talk a lot about this distinction, but these tools that are available to us really can improve our trust in machine learning system in terms of fairness, unbiasedness, robustness, and reliabilities over time. So we have mostly worked in the field of explainable AI and less in the field of interpretable AI, and we really put TRI really at the center of our AI workflow. Yeah, our AI cycle. So this is really important to us, and it's gaining a lot of importance as we go in our development, yeah, as we proceed. This was really important also for environmental sensing, and it helped really improve the understanding of sensor behavior. I have some example on the next slide, and also improve the trust of the technology team into our methods. You have to imagine we do interact with people that with colleagues and experts that are expert in technology, but do not have, for example, an algorithm or an AI background, and it fostered really a lot of interaction between teams. It helped us really also give more solid explanation on what our algorithm was doing, why it was deciding for that concentration, why it was sometimes also making wrong decision, yeah, and then improving on it. So I'm just giving you now three highlights of what we did mostly from the field of explainable AI. So one thing that proved to be that I would recommend to you also, if you are dealing with regression model, for example, one thing we did was to start ranking and studying the importance of our features. So how much the features really contribute to the final decision of the model. There are several techniques. We select the Shep technique from the Shapley value theory, and why was this so insightful for us? It was so insightful for us because basically our features are also very closely related to the behavior of the sensor, yeah, of the material, for example, to the dynamic of the sensor hardware. Yeah, so saying, for example, that the feature is very important means also that we have to make sure that this feature doesn't drift over time or does not deteriorate over time. Yeah. On the contrary, some features were, for example, surprisingly not important. So we also asked ourselves why. So are these features redundant? So is this the information they are carried also contained in other features? Or the model simply cannot do much with this feature because this feature is not repeatable enough. So this part of the signal that we are extracting from the sensor is perhaps not repeatable, not consistent, or is too noisy. And if this is, for example, corresponding to the physical behavior or chemical behavior, in this case, of a certain sensor field, then we can perhaps try to improve it, yeah, not just with the algorithm, but also with some study of the material. Yeah. So another interesting analysis we did was to look at the different unit of our GRU network. And we were very happy to discover that actually this unit had many of this, so most of them had a rather interpretable behavior. So, for example, we looked at the negative and positive activation in the presence of one gas or the other and varying the concentration of these gases. And we realized that this is just one example unit, we had many units, so I could not provide them on one slide, but just to give you an idea that we could visualize, for example, which units were learning one gas, which units were learning the other one. Some units were just learning the gas above a certain concentration or below a certain concentration. So they had a rather interpretable behavior that also increased our trust in the fact that we had the right architecture and we had also the right number of units in the architecture, which is also another parameter that you have to optimize. And then another important step that we took was to look at epistemic, and we're actually doing this also as I speak, looking at epistemic and aleatoric uncertainty into our data. And why is this important? So this is important because as I said, we are not the one actually taking the measurements. So we get the data and we analyze it, we characterize it. But these measurements are rather time consuming. So we measure sometimes for hours or days. So they are really keeping lab and the lab colleagues busy. And as such, we often get asked the question, okay, here is a new version, slightly new version of the hardware. Do you have now enough data? Are you happy enough? Or do we still have to measure? Or you still need one more profile, one more gas protocol? So we decided we'd try to quantify this to be perhaps less qualitative and more quantitative in our answers. So we started looking into Bayesian dropout and Bayesian neural network to quantify it, for example, at least the epistemic uncertainty. Yeah. And this helped really a lot also in the interaction with colleagues from the lab. So now we come really to the third part. So this third part is about calibrating and deploying AI on our sensor. So by now you have understood what our use case is, right? So we have a lab where we measure our sensor in a chamber, we expose them to gas mixture, and we have analyzer. These analyzers are very expensive devices that are giving us the ground truth for our supervised learning. Yeah. So once the model is trained and we are happy with it, and we have a first assessment of performance, in terms of relative error, R2 score, a minimum absolute error, and so on. We embed then this model together with the algorithm on our device. Yeah, and this device now is actually a product, it's a consumer product that has to work for a certain number of years. Yeah. So this is an example that I want to share with you of an outdoor measuring station. This is actually on our premises at Campion here in Munich. You see the analyzer and you see the boxes where our sensors are in. And these analyzers are capable of collecting, they basically measuring the same air as our sensor. And this information, so what is the exact concentration of the gas is being saved uploaded together with the sensor data on our cloud space, so to say, and we generate our database. So then later on offline, we download all this data and we apply the model that we have trained in the lab, and we see if it works and is giving us satisfactory performance from calendar week to calendar week. So here you see really the relative error, for example, for local sensor that we were studying at the end of last year. And just to give you an idea, for category 1 local sensor, the accuracy requirement is around 50%. Yeah. As high as it seems, this is actually the best category for our local sensor. So okay, this is very good. So these are like 6 weeks of performance that we have collected. But what are the challenges here? So the challenges that we are still talking, remember, about local sensor, right? Accessible to everybody. And they are subject to drift over time. And also depending on their interaction, on their cross sensitivities, for example, with other gases or other quantities like temperature, pressure, or humidity, right? So the causes of the drift might not be completely known at the beginning during your training phase or in the 0-hour calibration phase. And this cross sensitivity and also the drift, also that results of it out of them can be seasonal. So it can be different in winter or in summer, and it can be location specific depending on whether you are in Europe, in Asia, or in other geographic location. And of course, the drift can not just affect the baseline of the sensor, meaning that the response at zero gas. Yeah, so the value of the resistance that we measure when there is no gas, this can vary over time, but also the response of the sensor to a certain gas concentration. So this is now an exaggerated picture of how then the sensor response will look like in the presence of very strong drift. It's not so strong, but just to give you an idea. So things will just slide away over time. So what can we do? So there are, of course, a couple of standard methods. This is, okay, we can try to collect more field data. We can try to characterize them, to mix, so to say, field data and lab data. Yeah, we can try to model this. There's two kind of the techniques that can accelerate basically the effect of drift, so that you know more or less what will happen after certain time, and you can then try to compensate over time. So incorporate this into your algorithm. Or depending on the application, the infrastructure you have available, you can also think of just recalibrating, taking this sensor out of the field and recalibrate them periodically. So these are important challenges, but yeah, the good thing about challenges is that challenges also bring research opportunities for us as AI experts. So one topic that is gaining a lot of importance, being debated a lot in the environmental sensing community, is the topic of on-the-fly calibration. Yeah, so this really opens a box of a lot of possible techniques, and candidate methods, so to say. So for example, you have the possibility to combine batch and online machine learning approaches. You can explore transfer learning and few-shot learning to speed up model calibration when, for example, a few reference sensor and reference sensor data becomes available for the specific gas that you are targeting. So you can explore all this learning techniques, additional learning techniques on top of those that you have already designed when you were calibrating the sensor in the lab. And then there is a topic that is also very dear to me, that is the topic of also modeling the sensor. So generating on top of measurement data, also synthetic data. So creating what people call nowadays like how can I say, a digital twin of our sensor. Why it is so difficult? Well, it is so difficult because these sensors are new. These are completely new technologies. So there are some, we do understand their working principle. There are some equations describing what's happening, but this equation do not map directly then, for example, to the specific material being used, do not scale down automatically to the specific material, to the specific temperature size of the sensor that we have produced and developed. So with the help of our measurement, however, we can combine this knowledge that we collect from the literature with the measurement, try to create then a model really tailored to the specific sensor. And when we have a model, we can do actually a lot of cool things. So, for example, we can start thinking about the sensor not just as a standalone sensor, but as a sensor within a sensor network. And we can start thinking, for example, okay, if the sensor now is part of a network of sensors and can get a sensor from neighboring device that experience a similar condition, environmental condition, can I make then my algorithms, for example, better? Can I use this information and, for example, detect defects, like shown here in this confusion matrix, or detect, for example, sources, or detect or compensate for drift, or pollution sources and so on. So lots of very exciting topics can be enabled also by the availability of a sensor model. So, yeah, this basically brings me already to my summary slide. So we talked about AI, machine learning processing for environmental sensor tonight, and I show you how these techniques are indeed offering competitive performance over state-of-the-art approaches and can be embedded on small devices. This is also very important for us for edge AI. But we also seen how machine learning AI techniques and explainable AI techniques also helped us characterize the sensor and define the product specification. So identify the limit of our sensor and also adjust product specification to them. And yeah, and we talked about challenges as well. So the challenges of achieving a stable calibration of the sensor over space and over time. And we have seen our modeling of the sensor, but also innovative learning frameworks can indeed play a big role towards a stable solution. Yeah. And talking about the future now, what we often realize that what we have learned by now in the team in terms of AI analytics, sensor modeling, algorithm embedding, and electronics actually can be leveraged to explore new applications. So, for example, what we have learned for outdoor air quality monitoring can be extended also to breath analysis, with of course some difference, but it can also be used to used and extended, for example, to new senses. So to, for example, like liquid sensing, of course, is also important. Environmental liquid sensing is also important, right? And we believe that what we have learned over the years could be very valuable as we move also towards new application. But of course, the most important things to mention is that identifying, developing, and then validating the right sensing technology is still a big challenge, yeah, for a semiconductor company, and still AI can help us there. So this is really the end of my talk. I don't have a lot of publication here, but if you want to learn more about our work, you can perhaps already read some of the patents that we have filed over the years, yeah, and some publication we do have related to our TinyML design, but also related to our modeling activities. And yeah, at the end of the slides, I'm not sure if the slides are being distributed afterwards, but there are also 2 pages of publication from environmental sensing, also from other areas that have inspired some of the work presented here. So thank you. Yeah, and Lorenzo, I'm handing over to you at this point.
Thank you so much, Cecilia. It's such a pleasure after such a beautiful talk. Thank you so much. Yes, I am Lorenz Cervelay. As I was mentioning, I am part of Infinion, but also I'm part of TUM as well. I'm a lecturer in the Department of Electrical and Computer Engineering. And I'm here to present a little bit what Infinion does for the academic world and how the two things interconnect. And basically, we are trying to, at Infinion in general, as you have been hearing in the talk of Cecilia, we are state-of-the-art methods or very interesting methods that are discovered in machine learning that need to be used for improving our products. And in order to do so, we need to have a solid academic background. We need to have a bigger understanding of all what is explored in universities or institutions. And so for that, this started basically our cooperations with TUM in particular. And so at the beginning of March, Professor Wille, which has been also my PhD supervisor, opened at the Technical University of Munich, opened the chair of design automation. And here is where I'm actually teaching. And my class is called Machine Learning Methods and Tools. And the very idea of the class is trying to join really like the theory and the application part. And that's a little bit the scope behind. So what we want is, of course, having a solid theory. We want people to understand why things have been adopted and how different method and algorithm work. At the same time, we want people to be able to implement them. We want students to have some practical experience, and therefore our class is divided between theory part and also lab part. And I think this combination, so where you explore what you learned into basically hands-on exercise, this is what is the very value of the class and why we are so happy at Infinion to promote this idea, to combine theory and application. So this semester, So the class will be in place also from winter semester as well as summer semester. So it continues throughout the year. You're very welcome to register if you want. We had more than 200 registration for the class, and we have a lot of possibility also for offering also as well industrial experience to students. So what they learn in the class can be also adapted to Infinion itself, and they can continue also their experience. So the topic we go into is mostly related to the standard machine learning, algorithmic, and basics, and also we shift towards the end of the class more into deep learning. With external lecturers as well that are giving keynotes, and also we have some particular insight in state-of-the-art research where we really delve into what is the current state of different universities. So we have a wide range of different teaching material. So this I would like to sponsor it here. And this is my 8th semester that I'm teaching there. And so far we have good registration. So I invite you to check it out. Said that, on a more practical part or a more industrial part, I'm also a member of the Advanced AI group. We are a small group of corporate research where my two colleagues Alexandra and Suvik Hadra are also, and we are bringing on the concept of corporate research inside Infinion, in particular related to radar sensors. So we have basically one part of our knowledge which relates to signal processing for radar, and another part of our knowledge which is instead more related to the machine learning part and algorithmic, the same that has been taught actually in the class. And topics where we are mostly keen on, or that we approach currently, are reinforcement learning. For example, once we want to track different people having radar, we want to have some mechanism for performing even a better tracking, and there we use, for example, reinforcement learning. So this is one of our some topics. Also, we want to explore domain adaptations, so see how different sensors adapt to different rooms, which is something which is actually very important once you have a product and you want to deploy in different environments. So we are also researching on that. We have metric learning as a method in order to improve even more our classification, count people in a room, or detect, for example, the heartbeat of people through radar. So we have some method which improves supervised learning algorithms, and also geometric deep learning. So we also explore input methods which relates more to, for example, point cloud, algorithmic, and so on. So all these very new trends in machine learning are applied in my team, and also we try as well to not only take algorithms and apply them. If they have good results, that's welcome, but also we have the expertise also to modify this machine learning algorithm. So we kind of unify the applied world and the theoretical by also having our own innovation, our own solution. We do have, I would say, a fair research output. So we have 15 to 20 papers published per year within all the students and our team members, as well as we have a good throughput of patents. Since we are there, it's like around 3 years, we have more than 70 patents filed. So we have this very lean towards innovation. Also, we of course developed prototypes that then can be applied or produced in order to become exactly good products. I think, yeah, we can change the slide. And so related to what I was explaining to you, also about the class and about my group, we at Infineon have a lot of offer for different student roles. And so we can hire for internships, for longer internships, either mandatory or free internships or optional internships, as well as working student positions. We have master internship that are just, let's say, like a small introductory period to a topic, then will be the master thesis. So this is something that we are searching a lot. So someone that starts an internship to get acquainted with the whole framework at Infinion and the product and the algorithmic, and then start a master thesis. This is actually very welcome for us. We have real like bachelor and master thesis, and lately we are also having more and more corporate research, like myself, corporate research PhD students, which have really this advantage to experience both the scientific and the applied world. And also at the chair of design automation, we are starting a group with now seven corporate research Infinion PhDs, which have been supervised directly from TUM and a direct supervisor, our industrial supervisor at Infinion. Topics where we offer these particular these jobs or these experiences are research and development. So in order to have great and good performing products, we need to, for example, improve methodologies, how we produce them, how we design them. And this takes part in the R&D departments, which is, I would say, maybe one of the central places where we hire students in AI. But also we have AI in production. So for example, manufacturing, analytics, we are able, for example, to sense when something is created and have some anomalies during their production. And this is, of course, central for Infinion. So we are able to have a more efficient pipeline to develop our products. And also AI in supply chain, so in logistics and forecasts of demands, that's also very central in the semiconductor world. So this is also where we actually have our focus. And finally, for central functions. So for example, for business intelligence or customer relationships and or marketing, all this typical central functioning area. But I invite you to actually visit our two websites or our two pages that are in our website. So if you want to search for a position, /Infinion/careers, Infinion.com/careers is the good address. So that, I think, for my part, we are done. And thank you so much.
Thank you so much also from our side. It was great to hear not only the insights how Infinion is using AI to deploy it in its products and sensors, but also how you're the leader to push the semiconductor industry to go into this carbon neutrality. We will start the Q&A session in a moment, but before that, I will also add quickly on Lorenzo's short talk about the machine learning course, Methods and Tools. I actually also took the part some time ago already, and yeah, I could definitely recommend. So starting with the very first question, and that is, you mentioned that the data from the air quality sensors is used to make traffic management decisions. Is this more real-time or to inform long-term changes?
This could be both. So, of course, the long-term changes are also very important, yeah. But also there is a lot of, for example, research also trying to use this data to identify pollution sources. This is a very important topic. So this is rather long-term because, and you need to analyze this data over a certain amount of days to understand, to make sure that this data is not seasonal dependent, for example, but it could be in the long term also real time. Yeah, definitely for to decide on which path now to take to go jogging or to go for a walk, you would like this to be real time. Could be both, yeah. But of course, we are not there yet. So this is really there's a lot of work in progress and a lot of really great researchers combining even robotic and reinforcement learning to identify gas sources, pollution sources. A very, very exciting research area with already some results.
Yeah, adding on that, who would be then the main customers for the air quality sensors? Would it be cities? And what use cases are there for air quality sensors in the private sector?
Yeah, could be indeed cities, but could also be consumers. So people like us that would like really to have access to this information at the granularity that you need. Yeah, could be for the case of indoor monitoring, where we as Infinion have already CO2 sensor. Could be even, for example, schools. Yeah, that would like to monitor the air quality in their classrooms, and if the air quality is no longer that good, for example, ventilate, open the window and stuff. So it could be really both private, but also institution and organization. Yeah, conference rooms, companies. Yeah, that would like to monitor this. Yeah.
And with the rising pollutions everywhere in the world, I assume that this will be a very, very high importance for the upcoming years. I guess we're in Germany, we're quite lucky when it comes to air pollution, but there are many parts of the world that will definitely benefit from this. Coming over to the next question, and that is, do you also try to predict the air quality for the next few hours, days, using historic and weather data, or are such predictions not needed?
We don't do that, but it's possible. So for our products, we don't see now the use case for that, but in principle, it is possible. If you have a large amount of data for a specific location, there are indeed a lot of time series technique, predictive technique that can help you to do that. You could also think of combining this prediction, long-term prediction, with your short-term prediction to even improve or guide your shorter estimates. So this has also been, I've seen this as well. But in our case, for our products, we're really predicting, we say predictive, but it's in depth detecting the concentration of the gas that in the air that we are breathing now.
Okay, great, thank you. Coming over to the next question, and that is, with satellite technology advancing, do you think that in the future on-site sensors will be replaced by satellite measurements?
Satellite measurements are important, but indeed in urban scenario and crowded scenario, they cannot replace the local measurement from a small sensor. So you can, however, think of course, of combining and enhancing then your knowledge by using both sources. But again, especially in crowded urban scenario, you will still need to have smaller local devices. Yeah.
Sure. Coming then to the next question, and that is, having worked with IoT a bit myself, I know how important it is that sensors have a long battery life. Are you using low power communication methods like LoRaWAN and NB-IoT, or how do you tackle this challenge? This is a very interesting one.
Yeah, I mean, we don't, the aspect of our activity is still still in its early phase. So we do not have, we can enable, of course, connectivity. It can be Bluetooth, it can be Wi-Fi. This is possible, but there isn't an official protocol yet, or an official standard for this type of devices. This is, for me, also coming from the field of wireless communication, telecommunication. I'm always very surprised how very little is being standardized so far for this application, but we will come to that. Definitely low power is very important. That's why it's important that our machine learning methods and our algorithms are low power and have low complexity. Unfortunately, however, we should also say that the sensor per se are not necessarily low power. They are not necessarily low power, so the sensor hardware per se, because as I mentioned in one of the slides, they also need to be heated to clean them after absorption event. And as such, this is the biggest source of, say, power consumption more than the algorithm itself. Yeah, so this should be said as well.
Maybe one thing to add on this IoT aspect, because it goes beyond the connectivity on this sensing solution, this IoT solution. In the end, it's also a matter of executing these inferences very power efficient, having a complete system set up that allows this power efficiency, providing this local processing capability as an example, finding effective ways of running such an inference, computing this inference inside the devices, etc. And this is a big area where we also develop solutions to this specific demand. So really battery powered devices as well that have this local processing capability, etc. And of course, once this comes into play, then you have to look at the complete system setup, security topics, etc. need to be covered as well. Very important aspect. So it's really a kind of a round picture that you have to look at, and that's what we are developing to bring it to the real life. Really, I think this is a strong market, especially in Europe. IoT and automation is a strong market in Europe, and that's where we can provide the solutions for.
Perfect. Then coming to the next question, it says, a few days ago, we had a talk from Sebastian Schaal from Luminovo, who brings AI into the design process of electronics. Does Infinion also have AI solutions that help in the design process of electronics? And if yes, are they developed in-house or from the third parties? And if not developed in-house, why not? And also, are you using AI like through the whole process?
Yeah, maybe I can say something about that because it has been my PhD topic. So yes, I mean, we do have departments at Infinion that works on the design, and as introduced also in the slides, we are actually trying to make use the best possible use of AI in all what the semiconductor and our production and R&D is. So in that case, yes, we do. And again, I worked on that, and there are many methods that we developed during this part, and other people continue in my work. So yes, we do that. There is also, of course, a part of the design which comes from the tools that you use, and that are other companies. But Infinion itself is also trying to make the design more efficient, having better power performance, having less area for our microchips. So all of these are problems that we are tackling, and AI is just perfect when you have a lot of complex solutions and complex objectives that you want to minimize. AI is just the good method for that once the complexity scales up. So yes, in that, I would just summarizing, yes, we are active in that, definitely.
I can maybe add to this if I may. So I would just confirm what Lorenzo just said, but to say this goes along the entire chain of the design, starting from the initial design of the circuit that we want to. We have to take trade-off decisions, find the optimum for these. We have to model circuit behaviors, as we have seen also in the previous slides as well. It goes all the way to the layout processes, but also to the verification path, making sure that we find exactly these boundary conditions of operating ranges, etc. This is all cases where AI plays a role, where it helps us to find better solutions to optimize the flow or to speed up the development processes. And this is true also for the other, not only for the design, but also other processes inside our company. That's what we try to say there. And in the end, do we do this in-house or do we do this externally? It depends. Of course, it always is closely linked to the data that we have, how the data is available and how it's being processed there. It requires a deep understanding how the things are connected inside. For some of the things, there are solutions available on the market, and that there's a good reason to use them if they are available on the market. But many things are really new, specific application, and that's where we, of course, then drive it forward ourselves inside. And we have a large ecosystem of partners. Maybe just one thing to mention, also commercial companies, but also startup partners here that we work closely with, depending on what solution we're looking at. Yeah.
Amazing. Thank you for your answer. That was actually one of the next questions as well, if you're collaborating with the startups. But I think that we have it now covered. Coming to the next question, and that is, just give me a second to have a brief overview of the Slack channel. This might be off topic, but a friend of mine is working on giving electric car batteries a second life. He said that here AI and digital twins are necessary to speed up the process of measuring the remaining battery charge. As Infinion also sells battery management systems, I was wondering if you're also working on this problem.
Yeah. I think electromobility, of course, is one of the big topics of our organization as well. And as part of that, we are working on solutions for making the charge and also the battery control in the vehicles. So this is part of that. But I think as of now, I would not go into the details what specific solutions we're working on.
Great, then let's.
We had, however, looked at the use case of leakage from battery and using gas sensor to detect that. That could also contribute to make also the whole thing, the entire thing, more efficient. So this I know.
Perfect. Also, for all the participants watching right now and watching it later on, you will be able to contact our Infinion experts later on through LinkedIn or some other channel. So just if you're interested in some topic in more details, feel free to touch them or to contact them. Coming over to the next question, that is, measuring the CO2 footprint of products is becoming mandatory and increasingly important, as we saw with the big partnership between BCG and SAP recently. How do you, as Infinion, keep track of the CO2 footprint of your products? This is now more off topic of AI, but maybe you can also have a short word on this.
I think we briefly touched on it in one of the earlier slides, that we're really keeping track of this, and we are having programs installed really to make sure that we reduce the CO2 consumption that we have with the work that we are doing with the production of the semiconductors. This is being tracked, and we have committed ourselves to the target of CO2 neutrality. So there's corporate programs running on this. And of course, everything that we do in every organization that we do, we give this a thought, really, how this can be done. There's a number of ways how AI can, for instance, optimize the energy consumption or material consumption or waste being produced in the manufacturing, how we can reduce electrical consumption as well. This is not only true for what we do in-house, but of course what we enable at the customer side, looking at energy efficiency of major home appliances, etc. This is where the electronics and to some extent also AI in these control systems makes a contribution. So we keep track of that, we analyze this, and continuously innovate on finding new solutions to further reduce.
Great. Then another question for Cecilia or Lorenzo. Answering a previous question, you mentioned that the machine learning models has to be energy efficient and have low performance requirements. Are there any ML libraries that you would recommend that are designed to achieve this? For example, is TensorFlow Lite or similar already minimal enough?
So TensorFlow Lite is, I'm answering first, then Lorenzo, you can go. It's definitely a good address. So we are familiar. I mentioned many times this TinyML Foundation with their work. In the case of our application, we actually we even wrote our own library, because it was the inference was so simple and was so actually easy actually to compile and to really transfer our Python library into C library. So we went for it. But of course, the popular book from TinyML community should be recommended if colleagues want to look into this efficient AI embedding. Yeah, definitely TensorFlow Lite as well.
Yeah, same for me. I also worked nowadays less. So nowadays we just work mostly on the algorithm. But before, during my PhD, I worked a little bit on implementing that on embedding, and yeah, TensorFlow Lite, TensorFlow Micro were our case. But because of our hardware, we, as Cecilia was mentioning, we most of the time also took those libraries and modified them in terms of that they would adapt, for example, to our sensor or to our chip. And that has been like something that we have been doing consistently. So yeah, starting from either TensorFlow Lite or TensorFlow Micro, and then mostly going through that. We just as a side note, we have been in embedded system. We have always been more comfortable in working actually with TensorFlow products than, for example, with PyTorch, because of the whole chain that they offer in terms of embedded system. And that has been like something that we went through, we explored, and we understood from this tooling actually.
Great, thank you. We'll have last question, and then the rest, I suggest that the participants just forward them to you via email or LinkedIn. But the last one is, do you think that instead of using air quality sensors, we could just create a digital twin of cities, and then based on traffic data, maybe from cameras and other sensors, we can simulate the air quality?
Oh, that would be wonderful. Is, however, still very futuristic. I can only tell you that even creating a digital twin of a sensor is really challenging, because our technology is evolving as we speak. Yeah. But I do see the advantage of having model. I come from the area of telecommunication, where we design algorithms for entire modern platform just based on simulation and on simulated channels, on simulated transmitter, receiver, and RF impairments, and so on. And this is definitely missing in the area, and often in the area of sensing. So I do encourage you also, as a researcher expert, to look into that, and also to think even further and beyond the model of the sensor, as this participant was asking. So I'm a big fan of modeling and digital twin, as you might have understood. So any ideas is very welcome in this area.
Hopefully we can see it very soon out there. Thank you so much, Infinion team. It was our pleasure and our honor having you on board. I'm sure everyone enjoyed the talk, and will rush to contact you afterwards. Before we go into the break, we will shortly introduce you to what's coming next. So in a couple of minutes, we will hear Roche and Healthcare Explorers talk more about some very, very interesting topics. But then tomorrow, we also have Infusion Expert Talk and a Deloitte talk on Friday. Tomorrow, also something very, very interesting happening. That's a partners launch. So we'll hang out again in Gathertown. We will even have colleagues from Infinion and Roche out there just to share some expertise with us, and also share some knowledge and insight in a very, very relaxed setting. Then on Friday, you will actually have a chance to kickstart your Makeathon making phase and start working on the challenges. And it will last until the Sunday, where you submit the projects, and in the final or the track jury, and then finally in final jury, present and pitch your solutions. Before we actually really go to the break, you also have a chance to join our TUM.ai team. Application phase is actually open, so you just have to scan this QR code and land to our website, and also see what is actually TUM.ai about, what is there for you, and submit your application in just a couple of minutes. Now we go on a short break. It was supposed to be a 10-minute break. Let's make it a 5-minute break and continue at 8:23, and then we will hear more about Roche.
Thank you.
Thank you so much.
Goodbye,
Bye-bye.
everybody.
It's been a pleasure.
Bye.
we've had. We're continuing now with a talk from Roche, Xplorers Healthcare, and we will hear Roche's experts, Nadia Schäfer and Fabian Schmich, telling us more about AI in Roche and what they do actually to improve pharma industry. So Fabian, I hand over the stage to you.
Well, thank you. Hi, everyone. I'm really quite excited to be here with you tonight, and together with my colleague Nadia, talk to you about how we at Roche leverage AI in research and development to improve patients' lives. And I'll start off with a quick introduction on Roche and how we do R&D in pharma research. And then the main part of the presentation will be a walk through recent use cases we've worked out in the field of pharma and AI. And then Nadia will take over and talk to you about our Healthcare Explorer system program, should you want to get connected with us and get hands-on experience in pharma AI R&D. So without further ado, a few words about us as a company. So we're a fairly big company. We're around 100,000 employees worldwide. We run R&D in many different sites. And we are actually among all the pharma companies, the #1 company to invest the most in R&D research, which we're quite proud of. And when it comes to Germany, the R&D and production sites are basically centered around 5 different places in Germany, mostly in the south of Germany. The closest site to Munich is actually Penzberg, 1 hour drive from the city. And we're not only doing R&D on this site, but we also have a fairly big production site here. But it's really like a company within the company. So we also have our own marketing and sales departments and so on. So it's really quite a large site with over, I think, 7,000 people in Penzberg. And what's quite unique about our site here in the south of Munich is that we're combining pharma and diagnostics. So pharma is in simple terms concerned with all things medicine, in oncology, but also other types of diseases like neurodegenerative diseases. And diagnostics is essentially about machines and test kits, for instance, things like the COVID test kit and so on. And in order to give you an idea on what this sort of terminology and clinical trials are about, I want to show this short clip here and then continue.
You need to share your screen. Fabian, you need to share your screen.
Right. Let's try that again. Can you see it again?
Just give us a moment, maybe in 5 seconds, start again.
Okay.
Perfect.
Is it coming up?
Yeah.
If you're interested in healthcare, you've probably heard of clinical studies, and you might know they're done to find out if experimental treatments are safe and effective. When experts talk about clinical studies, you'll hear expressions like double-blind, comparative, multi-center, or adaptive, and maybe also study arms, statistical significance, bias, interim analysis, and above all, outcomes. Complicated stuff. What's it all about? Clinical studies are designed to answer specific scientific questions. For example, what side effects does a new drug have? Does it reverse or stop the disease it's designed to treat? Is it more effective than existing treatments? Can it be given alongside other drugs that are used for the same disease? In each case, the answer must come in the form of scientific data, not the impressions or opinions of the doctors or patients involved. These can be influenced by many factors, which could bias the results. Studies are set up so as to make sure this doesn't happen.
Right, so can you the central building block basically of AI-related research for us in pharma R&D, and I guess also for many other domains, is the data. So Roche really invests a lot of effort and energy into collecting, creating data products, managing data, integrating data, and curating data. And it's quite a diverse set of data. So we work on genetic data, such as gene expression data or mutation data. We work on data that we call real-world data that comes from hospitals directly. We collect that in a big database called Flatiron. These electronic health records are basically the patient trajectories, the history of the patients along the treatment path. We also work on and collect data from sensors that can be from mobile phones, but also from smartwatches and fitness trackers and so on. And obviously also image data. So here you can see an example from IHC stained tumor tissue data, basically. And all this data, like I said, we collect, curate, and integrate, and this it's really the key for us to do meaningful AI-related research to support all sorts of disease-related questions that we're trying to answer. And with that, I'd like to jump directly into the first example that I brought with me today on deep learning-derived digital biomarkers for Parkinson's patients. So Parkinson's, for those who don't know, is a disease of the nervous system that affects mainly the movement. So it can range from just mild tremors in the hands and in the arms to losing your balance or having problems to walk. It can also affect the speech system. And what's quite good about Parkinson's is that in the sort of life of a Parkinson patient typically comes twice, on average, twice a year to see a doctor, as indicated by the blue dots here. Whereas the symptoms from sort of no symptoms to mild symptoms to very severe symptoms can be very diverse throughout the years, as indicated by the white and red dots, basically. And the problem is that the patient's recall period is typically also quite short. So only about 7 days the patient can remember. So whenever they come to the doctors, you sort of don't really get the full picture. And while this is a little bit unfortunate, we actually do carry a lot of sensors with us all day. And in clinical trials for Parkinson, we're actually handing out mobile phones and smartwatches to the patients to sort of overcome this issue of having this very undersampled data set for the patient journey. And what we're really trying to figure out is how well does the drug work? Does the patient have any benefits? Is sort of the status of the patient improving, or are there maybe any side effects and so on? And this is really something that is difficult to monitor on just 2 days a year. So what can we get out of a smartwatch or a mobile phone? It's quite amazing, really. So it can, you've all used these devices. You can use the touch or the force. You can imagine you can develop specific apps to do little puzzles and tests to really test the motor system of a patient. You can use the GPS, but also the accelerometers and the gyroscope to track a patient's movement and so on. And I'll come to that in a minute. You can also develop apps around sound sampling, sound from the patients to detect any difficulties or improvements in the speech system and so on. So there's really a large breadth of opportunities that you have based on these sensors. And just to give you an example, what can be done and what has been done, you can see my colleague Florian here walking on the floor in the offices, basically, and on the side you can essentially see the data that is being recorded by the gyroscope and the accelerometers on the XYZ axis. So this is sort of how the data comes in. So we provide the patients with specific phones. It's always the same phone or sort of normed and standardized. And these types of things then is what we call passive monitoring. So we're essentially always recording the sensors. This data is then transferred via Wi-Fi to the cloud, and data of the sensor is being collected. This data is of course typically not labeled, so we kind of can't see, don't know what the patient is doing at the moment. And with this sort of breadth of data, we're now trying to figure out what can we do to support the clinical trial teams that try to understand how a patient is doing on that particular trial. So there's actually a large field in this digital biomarker space, and one of the branches here is called human activity tracking. So there's a lot of ground truth data available already, and with ground truth I mean label data. So basically we have the connection between the sensor data that we can collect and whether the patient was, for instance, sitting, standing, jogging, walking up the steps and so on. And we take this ground truth data and the models trained on this ground truth data, and then use those to learn on our particular domain and on our data to understand this data better and get an understanding of how long, for instance, a patient is moving, how often are they getting up, or how their gait activity is like. And then we can really, on the sort of patient cohort level, compare differences between, for instance, patients that get a placebo versus patients that do get the actual drug, and see sort of with this biomarker differences, and for instance in the number of times a patient gets up, which is an indicator of well-being in the field of Parkinson's, for instance. So that is I think a nice example to show you how we could use digital biomarkers, deep learning on sensor data to support our clinical trials. Now jumping directly into the next example, it's about the disease of the eye, diabetic retinopathy. Very high level, it's a disease of the retina. So essentially, tiny blood vessels in the retina in our eyes can leak, and blood basically flows out of these blood vessels into the retina, and this causes the patients to have problems with seeing. And if you look at the real images on the left-hand side, you can see a healthy retina, one particular field of view, and on the right-hand side you can see the sort of small leakages. I suppose once they're sort of marked here, it's easy to see for the non-expert, but it's typically not so easy. But physicians, of course, have a good handle on basically detecting these different stages of diabetic retinopathy. And what we try to do is to basically automate this process of being able to detect this disease, and also being able to predict the progression of this disease. And this is the example that I brought in this case here, to show you a little bit on how that works. So you can essentially see that this disease has different stages, or scale. This is called the Diabetic Retinopathy Severity Scale, and this ranges from basically none at all to the eye being fully flooded by leaky blood vessels and everything between, let's say. And this is the sorts of images that we use for training. And in this particular case, we've worked on data that essentially is based on 7 fields of views at each particular time point that we see the patients. 7 images are taken, and we would like to predict, based on these 7 fields of views that we gather from a patient, whether in 24 months, in this case, the patient will have a progression of +2 severity in the severity scale. And the way this works is we take a deep neural network here to predict on each individual field separately, let's say. It's a binary classification in this case, whether a patient will have this increased severity at month X. And then we use another model on top of these outcomes to then combine these different fields, the information coming from these different fields of views, into a joint model that does the overall prediction for a particular patient at a particular point in time. And you can see that this works reasonably well in the AOC curve, and is a nice way that shows how you can essentially support physicians with an automated deep learning based system that can help grading and predicting the progression probabilities of particular patient in eye disease. Another example that I brought is from the field of digital pathology. So here we're trying to derive biomarkers for patients from tissue images, from cancer tissue images. And to give you a bit of background here, we're looking at colorectal cancer in this case. And in colorectal cancer, it's been shown that there are very distinct immune infiltration patterns to be observed, called infiltrated, excluded, and deserted. So what we can see here are small patches from tissue, cancer tissue, stained for different cell entities. So the dark purple cells we can see are proliferating tumor cells. The yellow cells are T cells, immune cells. And what we can see that in an infiltrated patch of the tissue, you can see that basically all the tumor cells are paired or covered or being attacked by immune cells. So it's a good mixing of tumor and immune cells, meaning that the immune system can kind of detect these cancer cells and fight them. Whereas in the excluded case, we can see that the tumor nests are basically being somewhat fenced out, and the immune cells that are floating around cannot really get close or into the tumor nests. And in the deserted case, we simply don't see any immune cells, T cells at all. These are very distinct patterns that have been observed in colorectal cancer, and we set out to develop a digital pathology-based system that allows to automatically, using deep learning technology, detect these types of patterns across patient samples, and thus allow to select patients that would benefit from a particular drug that, for instance, boosts the general amount of immune cells in tissue, or that tries to bring immune cells closer to tumor nests and so on. And the way we do that is typically we start with these large whole slide images. They can be really big, 50,000 by 50,000 pixels, up to 10 gigabytes. We patch them up to be able to train neural networks on them, and then use encoder decoder networks to replicate essentially annotations from pathologists that we have as a ground truth data set. So here you can see different colors denoting different types of cells in these patches, and we kind of try to replicate these segmentations or segmentations of the tissue into the different cell entities, and thus being able to extract the XY coordinates of the different cells to then, in the next step, perform spatial statistics on these types of XY mapped out cell entities. So here in red, you can see the different tumor cells, and in blue, the immune cells. And without going too much into detail, we basically borrowed statistics from the field of spatial statistics to quantify the amount of immune infiltration around cancer cells, and then basically use these statistics to scale that up to the whole, back to the whole tissue slide, essentially. So in each of these hexagonal tiles, you can then essentially see the detected patterns that we found, and that's basically coming back to the archetype patterns that I showed in the beginning: inflamed, excluded, and deserted. And we can then kind of color this grid over our tissue sample, and basically deem the different areas of the sample in these archetype patterns. And why? And just coming back to why we do this. So in this case, you can see that this patient, for instance, has a lot of pink excluded and purple deserted tiles. So this patient could, for instance, really benefit from a drug that tries to generally boost the amount of immune cells, or a drug that tries to bring the immune cells closer to the tumor cells to essentially fight off these immune deserts and excluded areas. So this allows us to really try and match drug and patients in a more successful way. And another example that I would like to get into is how we do machine learning on electronic health records data. So this is what we call real-world data, because it does not come from randomized clinical trials, but it's essentially data that we collect from hospitals, from consenting patients within the hospitals that share this data with research institutes. And I would like to walk you through an example of how we can use this data to improve personalized healthcare. So I mentioned in the beginning already a really big database that we built up within Roche is called Flatiron. It's a database that collects the longitudinal trajectory of a patient's treatment history. So from the first time they come to this to a hospital, to basically the different types of drugs they take, the different measurements, lab measurements, blood tests, and so on that were taken, and all the diagnosis and so on. So it's really a very wealthy data set on a large number of oncology patients, and it really allows us to leverage this data to train models that help us inform our ongoing clinical trials to make better decisions and choose the right patients to go on the right trials. The way this has been done, and is probably still done in many cases traditionally, is that when you start to run a clinical trial and you're in an all-comer patient population, there's typically no patient enrichment done at all. So your population that receives this treatment will naturally have a group of patients that show this effect, the desired effect of a decreased tumor size or longer survival and so on. There will be a portion of patients that show no effect at all, and there will unfortunately also be a proportion of patients that show adverse events and have severe side effects. And since this is an issue, of course, the ideal scenario, on the other hand, would be to really only select those patients that will, with a high chance, show the desired effect of the drug that were designed. But since this is very difficult to know beforehand, a sort of intermediate approach is what's called patient enrichment, where we really try to develop methodology and strategies that allow us to increase the proportion of those patients that are likely to show an effect, and cut down on the proportion of patients that show no effect or even have adverse events. And one of the tools that we developed in this context is called RoPro, and this is basically a machine learning model trained on these EHR, electronic health record database, that I've just introduced. And just on one slide, it's difficult to sort of explain all the details, but the model essentially combines different scales or different types of factors, such as lifestyle factors, the body mass index or smoking status, a lot of factors that are host-based, essentially. They typically come from lab tests, blood tests that the patient does, the albumin levels or NLR rates and so on, and also values that we can collect from the patient's tumor, like the tumor stage or the number of metastatic sites this patient has. And the model then combines all these factors into a joint prediction system that allows us to essentially on sort of every time a patient data set is collected, predict the patient's fitness or probability of survival at any point in time. And the way we use this then is in the clinical trials is after we've collected the patient variables, we can predict the fitness and can then make good decisions on whether a patient would be, for instance, enrolled in the clinical trial or not. And to take this one step further, and this is something we're basically just getting into, is the concept of digital twins. This can mean many things, but in our world, in the world of randomized clinical trials, what we're basically trying to do is when a patient first comes and we collect the baseline data from a patient, for instance, with a blood test, this patient is typically then going along the journey in the clinical trial, has several follow-up visits, and builds up the patient record database, let's say. And the digital twin concept essentially means that we train or have beforehand trained a model on similar data that allows us to, from the baseline initialization of this particular patient's data, allows us to create a digital twin model and allows us to investigate what would have happened had this patient taken the placebo or had this patient taken another drug, and really allows us to enrich our data with synthetic or hypothetical patient data, and gives us much more statistical power when we analyze the efficacy of drugs or the safety of drugs in our clinical trials. And with that, maybe just as a note, we're like I said, we're basically now really getting into this, and we actually have a PhD position open. So if any of the listeners think this sounds like an exciting endeavor, then do reach out to us, and we can talk. And with that, I would actually just sum up and show you once more this slide. We've talked about various different types of data. I've emphasized how important data for us really is to allow us to really apply the right models to answer relevant questions in all sorts of disease areas that we work on. And with that, I would like to hand over to Nadia and really give you, and she will really give you some pointers on how to get in touch with us and get involved in exciting AI work that we can do in the pharma R&D world.
Yes, hello everyone. This is actually wonderful, and all the really great examples Fabian just shared with you are part of our Healthcare Explorers program as well. And it's really about how you can collaborate with Roche in a very direct way. And Healthcare Explorers came basically out of these great ideas. You saw that AI is really making a big difference in healthcare, and that this whole branch is totally transforming at the moment, not only on the way how we treat people, but also on the way how we diagnose humans on certain diseases, and as well how we can probably in the future predict certain diseases. And Healthcare Explorers is about how can we collaborate with you on the academic level and to bring new ideas on these use cases to us, and how can we work together on them. Maybe you can click on the next slide. Yes, so Healthcare Explorers is our innovation platform. So it's not the traditional way of just collaborating with academia and to provide you with an internship. We really want your passion. We really want to know if you are interested in thinking a problem through and innovating on a certain problem, and this with a data-centric approach. So this is the reason why we leverage Healthcare Explorers and say, if you want to invent something new, and if you want to work in a compelling team, then Healthcare Explorers is the program for you to get in touch with Roche and to make your mark. And if you click again, this is what we want. We want out-of-the-box thinkers. It's not about the typical, you need to write your master thesis. It's really about you are passionate about a certain topic and you want to work with AI and data to find new solutions, in the best case, to bring healthcare forward in the future. And as you can see, there were just a few of the examples Fabian shared with you, but there are many, many more in Roche we are currently working on in different areas. So there's really a lot to do. And I haven't seen any of our business problems without data or applying AI in the future. What are we doing this year? So what are our objectives with Healthcare Explorers? We are just closing, and Fabian, if you click again, we are just closing our batch 5. So until yesterday, we had 7 exciting challenges, business problems online, and we got really a lot of interesting applications from students to work on these topics. And we will have another batch, and we'll post another set of business challenges in October in 2022. So we are organized in batches. It's not that challenges or business problems are shared with on a regular basis. No, it's really in batches, so you can also work on them. How does it work? And what's actually in for you as students? And if we go to the next slides, you can see for you, we want to give students and PhDs as well the opportunity to get new insights into real healthcare problems. So it's really, if you participate, you are not only working on a fake or a fake problem. No, you will apply for something. You can realize your idea with Roche. So you get this insight, you will be part of the team, and you can truly make an impact. And this is for us, I think, a unique chance where you can join Roche at an academic collaboration level to say, you can realize your idea in that particular project. So many of the examples you saw were also in the past part of our Healthcare Explorers program. And students had the opportunity to work in global teams on these particular challenges. And their ideas they presented in our Explorers camp when they were invited to share their idea, they could continue working on this and further develop this with more data. But overall, we really want to have a lot of fun. It's really about working together, collaborating across sites, across different disciplines. So it's not only about pharma. We have a lot of interdisciplinary teams already and challenges where pharma and diagnostics are working together. And this is also what we want to have here together. So it's really rewarding. But how does it work? And what should you do next time when you see our next batch to be live? So you should really go on the next slide. You can see you should start really screening our challenges we are posting. And please select the one that interests you most. It doesn't mean you necessarily need to be just from a particular area or study a particular topic. It's also important that you have a good management of your data skills and your artificial intelligence skills, and that you have also some creative ideas how to approach a certain problem and how you can help us also to think in new ways. The next step is that you will be selected. You get invited to our so-called Explorers camp. So we screen all the participants who applied with a proposal, with a solution proposal. So that's really important. It's not your CV that's interesting to us. So you are invited for Explorers Camp. It's really the way how you solve the problem. And it doesn't need to be bulletproof. So 3 to 5 slides to share your thinking, to share your idea is really good enough. But we really want to understand how you think, how you would tackle such a problem. And if you are really passionate about, making a mark. The next step is then in that you have the Explorers Camp, and there you are invited and you pitch in front of 3 other applicants, and also about in front of a Roche jury. So you may know already from the startup business that it's a very similar process, just with academia. So we invite the 3 best applicants. It's a virtual camp at the moment, still due to Corona. And we had a lot of fun in this camp because for one problem, we really had most of the time 3 different approaches in different directions. And more than once, we just thought how if we put student A and B together in one room with these different perspectives, something really great is coming out of it. And also this happened sometime that we hired more than one person afterwards in an academic collaboration contract, because it was just nice to see how these different ideas and perspective complemented to one. And the final thing is, if you get selected, then you can realize your idea with Roche. So you will be part, I mentioned this, of the project team, and you will work on this topic further. Yes, and concluding on that is actually on the next slide, we want you. And just that you get an idea, it's just a 1-year program. So we just had 4 batches. Now we are closing batch 5, but already now we had more than 100,000 page views. And it's really across the globe. It's interesting because it's really it can be from the US, that you are in Explorers camp with someone from the US or someone from Germany, from Switzerland, from India, from wherever. So we have really many different applicants. We had around 15 challenges up to now. This is not including the challenges we had now in batch 5. And you can see it's around 92 applications, which seems not very much because on regular jobs we have maybe around 70 or 100 applications per job. But it's not about the job. It's really that we don't want your CV in the first place. We want your idea. So that's really important. And we want people who really are passionate about driving their idea further. And yeah, concluding and having some insights into our alumni, we already had some that you can meet these people on the next slide. They are also, you can see them on LinkedIn. So Sophia, Madhushri, Ali, and also TUM were some of our participants who really got the contract. And you can see on their statements that they really enjoy to participate in Healthcare Explorers for different reasons. Some were really looking into emotional topics and finding a platform where they could realize their idea. And others also really like unconventional routes, as you can see, and just trying out some new stuff. So really feel encouraged. Everyone who participated and finally got the contract really enjoyed to participate. And yeah, so I hope to see many of you maybe with our next batch, who is starting then in October 2022. And yeah, I'm concluding with we want you, actually. On the next slide, you can see it. We want you. We want out-of-the-box thinkers. And we really look for people who like to drive their idea further and who are passionate about working with data in the healthcare space. And with that, thanks, Fabian, and thanks to the wonderful TUM.ai team. Yeah, if you have any questions, you can anytime connect with me also on LinkedIn. And yeah, feel free to ask any question you want to Fabian and myself now.
Thank you very much, Nadia and Fabian. Awesome introduction to Healthcare Explorers and also great showcase of the use cases and how AI models are deployed in the pharma industry. Maybe the TUM.ai Makeathon will actually be a great introduction or preparation for your Explorers camp, because on Sunday, participants will pitch their ideas and solutions several times. So maybe they can just warm up for the Explorers camp and then in October, kickstart with you. And now we already have a couple of questions. So we will start with the first one. And that is, we just recently had a talk from Siemens Healthineers. I'm wondering if there are any AI projects where you are collaborating, for example, giving access to Flaretron Health database or sharing data.
We are, of course, collaborating quite intensely. Roche is really a very big company, so I can always only speak for my sort of small slice that I know and that I see. So I don't know if any of my colleagues or in my group we're not collaborating with Siemens in particular, but we have really good connections to the TUM people, to the LMU people. For instance, we work with Fabian Theis together at the Helmholtz Center, and Carsten Ma and Michael Menden. We're running data science school together, essentially, where we have PhD students joining us, and this sort of little ad that I put out is also in this context. We also collaborate with academic partners in the form of postdocs. There's really quite a breadth of work going on, and Flatiron in particular, this EHR database is actually run like a company within the company. So they actually, you know, sell data products for anyone who's interested or needs this data to develop models and data mining efforts. You can essentially license the data from Flatiron.
Great, thank you. Fabian, actually, we have a couple of more questions for you. And one is on the topic of colorectal cancer. So was there a case where your system was able to detect cancer that was undetected before?
So the work we developed here is not so much for detecting cancer or no cancer. It's sort of one step later, right? So all patients that get enrolled on the trial are already diagnosed with colorectal cancer. We try to kind of, on one layer above that, try to find those patients that would most strongly benefit from one particular drug or another. So it's essentially a more fine-grained substratification of colorectal cancer patients that we were looking for.
And another question from the same participant: is the colorectal cancer detection system already used in practice to support decision, or is it still in research phase?
So we have used this system already to shape enrichment strategies for clinical trials that we're running now.
Great. Okay, then coming over to the next one. It is, I once tried to develop a navigation system that uses the gyroscope data instead of GPS. Trying to build that, I ran into the problem of drift. Drift that I could only fix by using a Kalman filter and calibrating with the GPS data. As your video on the biomarker slide showed the tracking being indoors, I wonder how you dealt with this, and as there is no data to recalibrate.
Yeah, so indoors there is no GPS or very bad signal GPS, but sort of I haven't sort of been directly involved in this project, but I know that there's a ton of pre-processing and smoothing and probably also Kalman filtering being done. There are a few publications out from Roche about this. So for sort of more details on how this is done exactly, one would have to look into these publications.
Okay, great. We will encourage our participants to also look into that. I'm coming to the next question. It is, I often hear people say that AI will replace doctors, but from the example you showed, it seems to me that currently AI is developed to be a decision help and not an end-to-end solution. So what is your say in this?
Yeah, I mean, I don't know, Nadia, maybe you also want to say something about that. I mean, from my perspective, yes, as a data scientist, we really try to develop decision systems and tools that support decision making by doctors, by people that run clinical trials and so on. I think in some domains, in the field of imaging, maybe in other fields, we're very close to having models that can in some cases even outperform decisions by humans or ratings by humans. But I think in pharma R&D in practice at the moment we're sort of mostly augmenting and supporting decision making with our AI solutions.
Yes, absolutely. I can only echo what Fabian was saying, but yeah, there are big steps going by companies towards being able to predict, but it's not a question about making doctors or clinicians obsolete. It's really about joining forces, and you have to imagine Corona is the best example. The amount of publication, for example, scientific publication that came out every day since the beginning of the pandemic, as well as the amount of more information that was around there. So a doctor or clinician is not able to, to screen all that data and information to make precise decision. And these decision support systems can just help and enrich and improve the quality of joint forces. And I think that's very important to consider. For me, it's not either or, it's really about leveraging everything we have to make better, earlier decision and more precise decisions. And also in a consumable way, not only for clinicians, but also for the human beings and joining forces here.
Mm-hmm. And I think just maybe to add on top of that, because it's a very important and relevant topic for us that we internally also discuss a lot. Of course, I think what you can definitely say is that the work of clinicians and doctors is shifting, right? And to give you an example, the digital pathology examples that I showed, I think what we try to take away from our highly trained and skilled people is very sort of repetitive tasks like detecting cells and things like that, right? So on a whole slide tissue, these types of things machines can do really well, and I think that those things have traditionally been done by humans, by highly trained pathologists, doctors, and so on. And now I think these things can be automated by AI, and the doctor sort of focuses more on integrating knowledge and insights derived from systems underlying and sort of focuses more on interpreting the data and making the right decisions rather than doing repetitive tasks that cost a lot of time and money.
And also, in similar topic, do you think that in the near future, clinical trials can be partly simulated and speed up using large data sets, something similar to digital twins? And if yes, what area do you see this happening first, and where might it be impossible?
Yeah, this is a really hot topic right now. So there is, and this is exactly what we're trying to get into now with the digital twin topic, with virtual control arms and so on. So to give you an example, in oncology, for example, in contrast to other disease areas, there are typically no placebos because it's not very ethical to give a very sick cancer patient a placebo where we know that there's not going to be any effect. So in oncology, the concept of digital twins and virtual control arms is very appealing because we can enrich these early trials with synthetic simulated data, and that would allow us to give us more statistical power to make the right decisions on efficacy and safety topics early on, and then prioritize the right drugs to go forward.
Before we dive into the Health Explorers questions, there are a couple of more on data science side. So for Fabian, if companies will be able to select the patients for a trial based on the outcome they want to achieve, is this not risking us overlooking possible negative effects?
Yeah, it's a two-sided coin, let's say, right? So I think that I didn't mention this in the beginning, but we're basically, or I am basically transitioning from cell and models into human. So in our world, let's say, we really are focused on showing that a molecule that we invented or designed does something at all, basically. So we're kind of have to figure out that there is a positive signal, and whoever asked that is of course right, that we in later phases of a trial need to sample a representative cohort of patients that will then also later receive this treatment as a drug. And this is quite a tricky business to optimize seeing efficacy signals early and the drug to generalize well enough on a representative patient cohort. So this is quite an involved topic, which is also statistically not so naive, let's say.
And another very, very interesting question. Healthcare data is normal private data and can be shared. So often companies have to use federated learning when developing solutions. I'm asking myself, how were you able to build a flat-run data set? Was all data anonymized? And did the patients give you consent to use it?
Yeah, this is true. This is a complex question. So federated learning is also something that we're at the moment actively looking into, because it's true that that it's not easy to share clinical trial data, and that sort of different companies joining efforts could sort of move molecules forward at a faster pace, which would be beneficial for everyone, for the patients and the companies. But regarding Flatiron, I just want to emphasize again, this is not clinical trial data. This is real world data. So this is data that comes directly out of the hospitals where patients diagnosed with cancer go to get treatment, basically. So this is not a randomized control trial where we develop molecules, let's say, but it's essentially data coming from molecules that are already on the market and prescribed by doctors. And yes, of course, all these patients contributing to this database gave their consent.
Mm-hmm. But I think this is a very important topic. We are highly discussing how to make data fair, we call it also. How can we share data in a better way? We have to say Flatiron and also FMI is on the US market. So the rules are different. So it's also different when we look into the European market, how we are able to share data, whatever data it is. And we are really looking on the legal side, on the contractual side right now, to be better here in the future, because this is really one of the important topics to work on, and which will definitely be a competitive advantage for the company who can share data in the best way. But it's also for the purpose of science, right? So we really have to balance what ethical questions are behind. How can we make right contracts to share the data better? And there are also things going forward into more open innovation approaches where you can access certain data to work on. So Project Monai, for example, from NVIDIA is such a topic you can also have a look into. But I'm convinced the future will drive us further into that direction. But it's a heavy question, and we are heavily discussing it from many different perspectives.
Great, thank you very much. The next questions are rather focused on the other part of the talk. So for Nadia, if I participate in the program, will I gain access to your data set to develop my own solutions?
This is depending. So actually, yes, when you are hired, you can get access to the data. We have many most of the challenges do not offer a data set in the first glance, but all the students who participated were really creative in accessing on open source databases to at least show their approach, their idea. And when these students are then hired, yes, they get access to the data and they can work with our Roche data as well. But then they have the Roche academic contract, and then it's possible. So we can't make them public yet.
Okay, interesting to know. Another one is I have some friends that are working on using sensor data to diagnose and monitor stroke and are interested to work with companies like Roche. Is there a similar program to Xplorers camp for startups that want to work with Roche, for example, or what is it?
There are two ways. So if you are, for example, a student team and you work on that topic, we are absolutely happy if you apply to our Greenfit Challenge. I didn't mention that before. We have also a Greenfit Challenge, which is open anytime. And if you have a very good idea like this, for example, you can submit your idea, and we will reach out to our partners and teams in the company and ask if we want to work with you as a team and so on together. Important is, yes, we need to work then in a university cooperation contract, or we also need to organize how we come together. So the contractual piece behind this is important, and you need to be it needs to be academic relation. Coming back to startups, yes, we also work with startups. So there is a whole area which is taking place, and actually there will be a huge event. Maybe you saw it with Bits and Pretzels, 28th, 29th in Munich, and apply, try to get some entrance. It will be a huge event, and there also startups will be there.
Great. And the very last question is, can I also participate in the Healthcare Explorers camp after finishing my studies?
This is actually, no. In Germany, this is unfortunately not possible. In Switzerland, we also have 1 year after the PhD, we can hire people, which is good. It's depending on the countries. We have made this possible if the teams, and this is what we try to do. But if you are hired in Germany, no, that's not possible. But if the team, for example, is in Switzerland, yes, the year after you finalized your study is still possible to be hired. But in general, it's really a prerequisite. That's why it's called academic collaborations, that you are part of the university still. And that we can strengthen collaboration with academia at that level.
For all those that might be interested, in the worst case, you can move to Switzerland in your final year and then leverage this opportunity.
Yes, but it's also the opportunity, for example, and this is really take the courage, even you haven't finalized your studies, take the courage to participate, you cannot lose. And if you are then maybe starting at Roche at an internship contract, you know the people. You should also consider this an entry channel to meet people, to meet teams, and to make your connection, to build up your network. And then I think doors are open when you finalized your studies. So this I can only recommend. Don't wait until you finished. Really try it out earlier.
Great. Thank you very, very much. It was an honor to have you on board and to listen what is going on in Roche and also Healthcare Explorers. And thank you again, Nadia and Fabian. With this, we close our official part of the second day of Deep Dive Days. I will also shortly show you the upcoming schedule. So for tomorrow, we have another expert talk planned for infusion, also in the medtech domain. Afterwards, we will have a partners launch where all of you will have a chance to talk a bit with our partners and sponsors in a more relaxed setting and really ask them everything that you maybe wanted to ask them during the expert talks, but also maybe find a way how to engage more in companies like Roche, or how to really get a tip, how to get into the Explorers camp or something similar. Then on Friday, we have the last talk that will be held by Deloitte. And then on Friday, we also kickstart the making phase, where you will have a chance to finally start with the projects, with the challenges, and then give your best energy and effort to make the best out of it. Another reminder is to scan our QR code and find out everything about TUM.ai and also apply for the next iteration. The deadline is 7th of May, so hurry up to be one of the first to submit the application. Thank you a lot for being with us tonight. All the talks will be recorded and published on YouTube, so you will have a chance to watch also some parts again. We look forward to seeing you tomorrow. And with that, bye-bye.
Bye.